friends, today we will be discussing about a topic called resting membrane potential. What is a resting membrane means? The cell is at rest. That means the cell is not undergoing any activity. If it is concerned with the neurons, the cell is not transmitting any electrical signal, because neuronal cells, one of the main functions is transmitting electrical signal. Okay, so the cell is at rest state. That means it is not undergoing any function. And before we go into the topic of potential, I want to explain about three topics called as concentration gradient, electrochemical gradient, equilibrium potential. Okay. So, what is meant by concentration gradient? Gradient refers to any difference. So, the difference in concentration between any two ions is concentration gradient. We will take an example and then we will understand these concepts. Let's say we have two beakers, and in beaker, let's say the beaker A and this beaker is B. We have 40 sodium ions here, and I am representing 10 sodium ions by 1 sodium, and 40 chloride ions here. In beaker B, we have 20 sodium ions and 20 chloride ions. If we connect these both beakers by a tube, naturally, by the law of diffusion, ions will flow from higher concentration to lower concentration. So, as this 44 sodium as in beaker A has more sodium ion concentration, these sodium ions will transfer from beaker A to B, and similarly chloride ions will transfer from A to B. So we will have 30 sodium ions and 30 chloride ions, and 30 sodium ions and 30 chloride ions. The force which is driving these sodium ions and chloride ions from A to B is concentration gradient. That is, the difference in the concentration is driving these ions from a particular point to another point. Okay, so the difference in concentration is concentration gradient, and there is a force generated due to concentration gradient. Okay, let's say if this tube is only permeable to sodium ions, again starting the same example but with a different case. So we have 40 sodium, 40 chloride ions, and 20 sodium ions, 20 chloride ions, and the tube is only permeable to sodium ions. So what will happen? Because there is 20 and here 40, 10 sodium ions will want to move from beaker A to beaker B. Then the force is concentration gradient, FC, let's say. Okay. In the law in physics generally, or in chemistry, there is a law called opposite charges attract each other and same charges repel each other. So sodium ions will get attracted to sodium ions and chloride ions will be attracted to each other. So there is a force on sodium to move from beaker A to beaker B. The force due to concentration gradient. If the sodium wants to move from here to here, or from beaker A to beaker B, the chloride ions will be left, or the force between sodium and chloride ions will stop the sodium ions from moving from beaker A to beaker B. And this force is due to electrochemical gradient. If these sodium ions move, let's say the force due to diffusion or the force due to concentration gradient is higher than the force due to electrochemical gradient. Let's say we have 30 sodium ions and 30 sodium ions in both beaker A and B. 40 chlorides in beaker A and 20 chlorides in beaker B. So this why because the force due to concentration gradient is higher than the force due to electrochemical gradient. Let's remember the force due to electrochemical gradient is the force between any opposite charges or the force between any like charges. That is, like charges repel each other and opposite charges attract each other. And that force between charges is the force due to electrochemical gradient. I am not explaining about the gradient, electrochemical gradient in detail. We will talk about it later. So there is a concentration gradient force. So in here, if we say there is a 30 sodium ions and 40 chloride ions in beaker A. So there is an excessive amount of chloride ions here. So this will make so this will give the beaker excessive negative charge. So this will have a negative charge, and this beaker B will have an excessive positive charge. So let's say we assign a positive charge to here. So in the first case scenario, where it is not where the tube is permeable to all ions, there is no assigning of any sign. When the tube is only selectively permeable to particular ions, we have an excessive amount of ions on one side and excessive amount of another ions on another side. It is positive and negative. So there is an opposite charges. One side we have positive, and other side we have negative. This is called as polarization. If anything occurs opposite to this